Assalamu alaikum. Before starting today's next question from the topic of kinematics, physics course 9702, the next past paper question, I want to share some answers which were being queried by my students after listening yesterday's question's solution. That was the question which is right now being flashed on your screen, what we did yesterday. Question is from kinematics topic, November 2024, paper 2-3, and that was question number 1. In all problems people have, I have realized that they need to stronger their concept of components of vectors. Just like as the people used to find out the resultant of the two vectors, similarly, a single yellow vector can be divided into two components. One is being shown in a green color and other one is being shown in a blue color. How many different types of vector quantities can be involved in this question or were being involved in this question when we were solving it yesterday? Obviously, you people can clearly see that we were dealing with the displacement in that question. So we can talk about the horizontal displacement or the vertical displacement, and obviously about the resultant displacement too. When displacement is there, then displacement per second is called velocity. Displacement covered per second is called velocity. So if we can talk about the horizontal displacement or vertical displacement, then we can also talk about the horizontal velocity or vertical velocity. Similarly, horizontal acceleration or vertical acceleration. And finally, the fourth quantity you people need to consider in your mind is horizontal force or a vertical force. So overall, these are the four vector quantities which are extremely important in the solution of most of the questions of kinematics. I repeat the names of those quantities, those vector quantities: displacement, velocity, acceleration, and force. So, beta, as you people have seen yesterday, that there wasn't any force in the horizontal direction. There wasn't any resultant force present in the horizontal direction. So, according to the Newton laws, if there wasn't any horizontal force present, it means it is impossible to have a horizontal acceleration or acceleration in the horizontal direction because F equals to ma, where F is the resultant force and A is the acceleration. So in horizontal direction, we can only apply the formulas for the constant speed or the uniform speed or the uniform velocity. As you know, that speed is the magnitude of velocity. While as far as the vertical direction was concerned, you people can now see, you people have seen yesterday that in vertical direction, there is a force. There is a force of gravity in the vertical direction. So if there is a force in the vertical direction, then according to F equals to ma, there must be the acceleration in the vertical direction. And whenever there is the acceleration, whenever there is the acceleration, we have to answer the questions of uniform acceleration. As in the vertical direction, the force remains constant in case of free fall. In case of free fall, the force due to gravity remains same throughout the journey of 63 meters. So if the resultant force remained same, it means acceleration remained same, or it was the case of uniform acceleration. So in case of uniform acceleration, you people can use your equations of motion like V equals to U plus GD S equals to ut plus half gt square or v square minus u square equals to 2gs. These were the queries asked from me, and I am sure that I have answered those queries appropriately about the yesterday's questions. Now, our today's question is once again from the topic of kinematics. 9702 is the physics course. This is from June 2024, paper 2-1, question number 2. The question is beginning from the definition of velocity. Your examiner is asking for defined velocity for 1 mark. The command word is defined velocity. So you just only have to say the change of displacement per unit time. Displacement is the already defined quantity when velocity was defined for the very first time in the history of physics. So we have imposed a condition on the displacement. And that condition is that whatever the change in the displacement happens for the moving body, for the moving vehicle in 1 second, that will be regarded as the velocity of the moving vehicle. So the change of displacement per unit time is an appropriate definition which can gain you 1 mark. The next part is a student throws a ball over a vertical wall of height h as shown in figure 2.1. So once again, you can see that our today's question involves the movement or the displacement in 2 directions. As you can clearly see from this diagram, the ball is thrown by making an angle with the horizontal, angle of 40 degree with the horizontal. And ball at the same time is covering the vertical displacement and also at the same time is covering the horizontal displacement. I want to say that at the same time the ball is moving from left to right, which is regarded by me as horizontal displacement. And at the same time, the ball is also moving from bottom towards top, which is regarded as the vertical displacement. So here there are two types of displacements are being involved. A displacement in the vertical direction, a displacement in the horizontal direction. So in the end, we can have the resultant displacement by combining these two. By if these are the two types of displacements, then we can have to handle or we should know how to handle the vertical velocity and the horizontal velocity. Obviously, the velocity in the vertical direction will be the rate of change of vertical displacement, while the horizontal velocity will be the rate of change of horizontal displacement. And similarly, we should remain alert throughout the question about the horizontal acceleration and or vertical acceleration. And we should remain alert about the horizontal resultant force and or vertical resultant force. So overall, beta, you people can notice, sit down, you students can notice that overall we need to talk about or we need to know about or we need to handle the four vector quantities: displacement or velocity or acceleration or resultant force. So let's see how to solve these questions next parts. First of all, the examiner is asking about the ball leaves the hand of the student at a height of 1.2 meters, at the height of 1.2 meters above the horizontal ground. The ball has an initial velocity of 22 meters per second at an angle of 40 degree to the horizontal. The ball is a horizontal distance of 36 meters from where the student releases the ball. As you can see that there is a horizontal displacement of 36 meters between the student releasing point, between the student's hand from where the ball was being released and the wall. There are 36 meters overall. Air resistance negligible. Determine the time taken for the ball to reach the wall. How much time is being taken by the ball to reach the wall? So once again, beta, you should be very careful about the vertical resultant force and or horizontal resultant force, as it is absolutely clear that the force is applied by the student, and once the ball is being released, now there is no force or no resultant force acting on the ball in the horizontal direction for the rest of the time once the ball is being released. So if there is no resultant force in the horizontal direction, it means there must be no horizontal acceleration should be present in the ball. Means no horizontal change of velocity. According to F equals to ma, if there is no resultant force, then there is no acceleration. So as there is no horizontal resultant force, so it means there is no horizontal acceleration. But as far as the vertical direction is concerned, you people, we all as the student of sciences knows that there is a resultant force acting in the vertical direction, which is the force of gravity. The force of gravity is producing the acceleration due to gravity, which is equals to 9.81. 9.81 is a positive value when the ball is moving or when a body is moving in the downward direction. It does have a negative value when the ball or any other body is moving in the upward direction. So we should be very careful about minus 9.81 or plus 9.81. So here the examiner is simply asking about determine the time taken for the ball to reach the wall. Like how much time is being taken by the ball to reach the wall. As you know, in the horizontal direction, the formula speed equals to distance over time can be applied here because in the horizontal direction there is no acceleration. If there is no acceleration in the horizontal direction, it means there is no change of velocity. And if there is no change of velocity, then the formula for the constant velocity, which is speed equals to distance over time, can be applied here. So I have applied that formula that speed, if speed equals to distance over time, if speed equals to distance over time, then I can use this particular formula in which it is being written that speed equals to distance over time. As you can see, that horizontal velocity should be equals to distance, which is 36 meters here. The horizontal distance is 36 meters here, divided by time. Time needs to be calculated. And simply, you people can see that uh, VH equals to 36 over time is in the horizontal direction. As we were saying, that speed equals to distance over time can be applied in case of horizontal displacement or in case of horizontal direction. So I've applied the formula where VH stands for the horizontal velocity. 36 meters is the horizontal displacement, and time is the unknown quantity which needs to be calculated. But you people can clearly see that there are two unknowns in this equation, VH and T. If we want to find out the value of time, then we need to calculate VH first. If we'll talk about, if we'll see the given data, then the total velocity, 22 meter per second is the total velocity which is being given here. And I need the horizontal component of this total velocity here. So if I draw a line here like this, follow my cursor, if I'll draw a line here like this, a right angle triangle will be completed. And according to the rules of the right angle triangle, in front of the 90-degree angle, 22 meter per second is present, which will be hypotenuse in this case. And base stands for the VH horizontal velocity, while the perpendicular will stand for the vertical velocity here. As I want to calculate the horizontal velocity, so horizontal velocity will be the base, VH. So VH divided by 22, which will be the hypotenuse, base over hypotenuse. 22 meter per second is the hypotenuse here, which is the total velocity. So VH over 22 should be equals to cosine of 40 degree. So from here, by cross multiplying 22 with cosine of 40, you people can calculate value of horizontal velocity. And by substituting that value of horizontal velocity somewhere here, finally you'll obtain the answer for time taken, and that answer will be equals to 2.1 seconds. It's very simple. The next root of the question is very simple. So I'm moving to the next part. Calculate the vertical component u of the initial velocity of the ball. So now your examiner is asking about the vertical component. As I told you that if I'll plot a straight line over here, a right angle triangle will be completed. So this side of the right angle triangle will be representing the vertical velocity, and that will be the perpendicular of the whole triangle. Perpendicular, base, hypotenuse. So just like as in the last part, in the last question, by using VH over 22 equals to cosine of 40 degree, we have calculated the horizontal component of the velocity. Similarly, the vertical component, which is being named u, small u, by the examiner, can be calculated small u divided by 22 equals to sine of 40. So by cross multiplying 22 with sine of 40, you people can obtain the vertical component u of the initial velocity of the ball. Now, the next and last part of this question is the ball just goes over the wall. Calculate the height h of the wall. The ball just goes over the wall. So calculate the height h of the ball, the total height h. Remember, the ball was released from a point which is vertically 1.2 meters above from the ground. And now here we want to have the total height of the wall. So in this case, we have considered the vertical journey. In case of vertical journey, we know the values. We know the value of 1.2 meters. And also you can see that the vertical distance of wall or vertical height of wall is being required here. So I have applied s equals to ut plus half gt square. You people can see that v equals to u plus gt or v square minus u square equals to 2gs cannot be applied in this case. Or if they can be applied, then our final answers will remain the same. So you don't have to bother about it. Whether the answer is different, if we'll apply a different formula, no, the answer will remain same if the data is enough for v equals to u plus gt or v square minus u square equals to 2gs. I think the data is enough in order to use s equals to ut plus half gt square. As an example, in place of u, we can substitute 29 meter per second. As you can see, in place of u, s equals to ud, we can use the value of you have obtained in the last equation. U was 14 meter per second. the vertical component of the speed was 14 meter per second. And here now we have started the question by applying 14 into 2.1. So as far as S equals to UD, U stands for the initial vertical component. As I have already told you that I'm considering the vertical journey here. So in the vertical direction, we have an initial speed of 14, 1, 4, while the total time of this journey when the ball released from the hand and reached the wall is equals to 2.1 seconds. So we have used the total time of the journey, which is 2.1. So 14 into 2.1 is being substituted in place of u and t respectively. Then plus half into minus 9.81. Minus is being used here because the upward journey is being involved here. And in case of upward journey, you always have to consider minus 9.81 instead of plus 9.81. In place of time, as we have already calculated in part B1, the value of time, which is 2.1, 2.1 whole square. And by using these values, you'll see that we'll calculate the height equals to 7.8 meters. The height equals to 7.8 meters. How have we calculated the height equals to 7.8 meters? This is the height from the point where the ball is released to the top of the wall that is being calculated by us. So if we want to calculate the total height of the wall, then we have to add 1.2 meters into it. So 1.2 meters plus 7.8 meters will be the total height of the wall, which is required here. And in this way, we'll conclude our answer equals to 9.0 meters. Thank you so much for today. Inshallah, we'll solve another question on the topic of kinematics tomorrow. Thank you. Allah Hafiz.